morning, children. So in the last period, we completed vector product between two vectors. Now we'll continue with the products of vectors. So in product of vectors, we studied about dot product between two vectors, cross product between two vectors. In this dot product, we defined A dot B as equal to mod A into mod B into cos of angle between A and B. And then the cross product between two vectors is A cross B is equal to mod A into mod B into sine of angle between A and B into n cap. So all this is a number. So some number into n cap is again a vector. So A cross B is a vector. Now suppose that you have three vectors A, B and C. A, B, C are three vectors. Then what all the products that can be defined between these three vectors? Suppose I take dot, both dot here, then A dot B dot C like this. A dot B is a number. A number dot vector is not defined. Vector dot product is defined only between two vectors A and B. So this is not defined because this is a number. Number dot vector is not defined. Now in the same way, A dot of B dot C is also not defined. Now suppose I take A cross B dot C. A cross B dot C. One dot and one cross. Then here A cross B is a vector. A cross B is a vector. So vector dot vector is defined. So A cross B dot C is defined. Now A cross B is a vector. Now vector dot vector is a scalar. Vector dot vector is a scalar. So this is called as the scalar triple product. It is called as the scalar triple product. Scalar triple product. Now suppose I put brackets here for B and C. Cross and dot are same, but if I put dot here, is this defined? No, because this is a number. A is a vector. Vector cross number is not defined. So this is again not defined. Now I take both cross. A cross B cross C. Both are cross. Both dot, one cross, and then both cross. So here it is a vector. Vector cross vector is defined. So this is called as the vector triple product. This is called as the vector triple product. Scalar triple product, and then this is vector triple product. So this is how we define, and we also have A cross B cross C. Even this is a vector triple product. So this vector triple product at present you don't have, it is in the deleted syllabus. So we'll be learning only about this scalar triple product. So what is this scalar triple product and how is it defined? So we are now going to learn about triple products between three vectors. In the triple products you have scalar triple product and vector triple product. So we are going to learn about the scalar triple products. So what is this scalar triple product? So as we discussed now, it is A cross B dot C. So this product between three vectors A, B and C, non-zero vectors, is called as the scalar triple product between three vectors. Now suppose that A cross B dot C is equal to 0. When can it be equal to 0? When A cross B is perpendicular to C. When A cross B is perpendicular to C, these are the two vectors. When they are perpendicular, their dot product is 0. So when A cross B is perpendicular, A cross B dot C is 0. This implies that A cross B is perpendicular to C. Or A cross B is equal to 0. Or A cross B is equal to 0. Or C is equal to 0. These are the possibilities. A cross B is 0 means what? When is A cross B 0? Either A is 0, or B is 0, or B is 0, or A is parallel to B, or A is parallel to B. So when this is 0, these are the possibilities. Either A is 0, or B is 0, or C is 0, or A is parallel to B, or A cross B is perpendicular to C. Now we'll see this part. A cross B is perpendicular to C. What does it mean? So now suppose that A and B are vectors in this plane. And you know this is the direction of n cap. A, B, n cap form a right-handed system. Now n cap is nothing but n cap direction is same as the direction of A cross B. What is A cross B? A cross B is mod A into mod B some number into n cap. So n cap direction and A cross B direction are same. So A cross B direction is perpendicular to the plane containing A and B. Okay, now next is suppose now we have one geometrical interpretation of this scalar triple product. Geometrical interpretation of scalar triple product. How is it interpreted? So we have a parallel, you know, cuboid. Cuboid means what? It is a rectangle. All sides are rectangle. It is a solid where all sides are rectangles. All sides are rectangles. This is a cuboid. Now, if all sides are squares, it is a cube. Okay. Now, if all sides are parallelograms, suppose that all sides are parallelograms like this, then this is called as a parallelepiped. This solid is called as parallelepiped. Parallelepiped. This is the solid. If all the sides of the solid are parallelograms, base is parallelograms, top is parallelogram, all sides are parallelogram, then this is called as a parallelepiped. Now here we'll take one origin. One vertex we'll take as origin. Now suppose that this side is A and this side is B and this side is C. So A, B, C are the edges, coterminous edges of the parallelepiped. Then the volume of the parallelepiped, is given by this value A cross B dot C. So A cross B dot C value is nothing but the volume of the parallelepiped whose coterminous edges are A, B and C. This is the proof is also there, that is not there for you. You just learn the formula A cross B dot C. Now suppose this is A, B, C. Now suppose I change this to B, A, B, C. Now this is, suppose this is A and this is B and this is C. Then again it will be C cross A dot B will be the volume of the same parallelepiped. So A cross B dot C is same as C cross A dot B is same. Suppose again I change the sides, then it becomes B cross C dot A. Suppose B, C, A like this, it is like that. Then the volume of the parallelepiped will be same. So A cross, it is the same parallelepiped. When you change the sides, the volume formula will become like this. So that means all these three are equal. So A cross B dot C is same as B cross C dot A is same as C cross A dot B. That means when the cyclic order A, B, C, A to B, this is A, next to B, next it should be C. Again C, B, C, A or C, A, B. A, B, C, B, C, A, C, A, B. When that cyclic order is maintained, this scalar triple product value remains same. So what we do is we denote this scalar triple product by this symbol. It is called as the box product. It is called as the box product of the three vectors A, B and C. So here one more property we'll learn, then you can suppose that we have A, so all the three are equal now. So A cross B dot C is equal to B cross C dot A. Yes, now we proved it is nothing but the volume of the same parallelepiped. Now dot product is commutative. We already know that dot product is commutative. So I can write A dot B as B dot A. B dot, that means B cross C. A dot of B cross C. Now if you observe these two, here cross and dot are interchanged. Dot and cross are interchanged. So that means in a scalar triple product, you can interchange dot and cross. You can put dot between any two vectors, and for the other two vectors, you will put cross. So we need not write any symbols here. So box product is the scalar triple product. ABC is same as BCA is same as CAB is equal to CAB. Okay. Now this is about the volume of the parallelepiped and also the scalar triple product. When the cyclic order is maintained, you can write the scalar triple product as ABC or BC or CA. Now if we come to this properties, A cross B dot C. Now if I interchange in the cross product, if I interchange the vectors, then I should change the sign now. So minus B cross A dot C. That means this is minus of box BAC. So this is actually box ABC. Box ABC. Now when I interchange the two vectors, here in the cross product, I should change the sign. According to our property vector product between two vectors, you should change the sign. So you will get like this. So that means the property that you have to learn here is when any two vectors are interchanged in a box product, when any two vectors are interchanged in a box product, change the sign of the box product. So suppose that I have ABC box product. Suppose I have to interchange these two. Then it will be minus of ACB like this. Again, if I interchange these two, I'll get minus 1. This is minus means minus 1 into. So again, if I interchange, I'll get again another minus 1 and I'll be writing CAB like this. So minus of minus plus, it becomes CAB. So ABC is same as CAB like that. Okay. So the property that you have to learn here is when any two vectors are interchanged in a box product, then change the sign. Now next property is, suppose that two vectors are identical in a box product. Suppose two vectors are identical. Suppose two vectors are identical in a box product. Then what happens, it is A cross A dot B. You can write cross and dot anyway. So if I write cross here between A and A, we know that A cross A is 0. A cross A is 0. So A cross A dot B is equal to 0. That means if two vectors are identical in a box product, then its value is 0. Similarly, suppose I have ACA like this. This is also equal to 0. If two vectors are identical, then its value is equal to 0. Okay, the next property. Next property is, suppose that I have some 2A dot 2A, some 3B, and then minus 9C like this. This is the box product. Then what is its value? You can just multiply the numbers. 2 into 3 into 2 into 3 into 2 into 3 into minus 9 into, take the box product between the three vectors like this. So this is how you simplify. This is the next property. Next, suppose that you have A is equal to A1I plus A2J plus A3K, and then B is equal to B1I plus B2J plus B3K, and then C is equal to C1I plus C2J plus C3K. Suppose you have like this ABC vectors, then you can write box product between the vectors ABC. Okay, before discussing this, we'll first discuss this property. What is the box product of IJK, unit vectors? You already know IJK as unit vectors. So what is it? It is I dot J cross K. I dot J. I can put dot and cross anywhere. Suppose I take I dot J cross K. What is J cross K? J cross K is I. So I dot I is 1. So IJK, box IJK value is equal to 1. Now, ABC, box ABC here. If ABC are in terms of ijk, then the box product is given by determinant of a1, a2, a3, and then b1, b2, b3, c1, c2, c3 into box ijk. This is the formula. Box ijk is 1. So even if you don't you need not write this. You can just write the formula like this. So box ABC is determinant of I coefficients, then j coefficients. I coefficients is first column, j coefficients second column, k coefficients third column. Write the determinant into box ijk. Now suppose that you have another 3 vectors like this. Suppose L is equal to some A1, I'll take L1A plus L2B plus L3C. Instead of ijk, it is in terms of some other 3 vectors. Suppose M is M1A plus M2B plus M3C, and then N is equal to N1A plus N2B plus N3C. Then the box product of these vectors L, M, N is equal to determinant of A coefficients, that is L1, M1, N1, next L2, M2, N2, and then L3, M3, N3 into the box product of ABC. Into the box product of these vectors ABC. This is the most general formula. So if it is in terms of ijk, it will be like this. Now this value is 1. So you will just write the determinant value. Okay. Next property is, next we have a theorem. Suppose that A, B, C are 3 vectors. A, B, C are 3 vectors. When they are coplanar, when they lie in the same plane, when A, B, C vectors are in the same plane, A, B, C are in the same plane, then their box product is 0. Then A, B, C value is equal to 0. So the converse is also true. That means if the box product is 0, then A, B, C are coplanar. They lie in the same plane. So the theorem states that if ABC are coplanar, ABC are vectors are coplanar, if and only if box ABC is equal to 0. This is the theorem. So first we'll assume that, suppose that box ABC is equal to 0. That means what? A cross B dot C is equal to 0. So that means what? A cross B is perpendicular to C. A cross B is perpendicular to C. Now you know A cross B direction is this. This is the direction of A cross B, and suppose A cross B dot C is 0. Then A cross B is perpendicular to C. And we also know that A cross B is also perpendicular to A cross B is also perpendicular to A and B. A cross B is also perpendicular to A and B. A cross B is perpendicular to C. That means A cross B is perpendicular to all A, B and C. So that means A, B, C are coplanar. So A, B, C are coplanar. They lie in the same plane. So we assumed that ABC, box ABC is 0. So we have written the full form like this. So the dot product is A cross B dot C 0 means A cross B is perpendicular to C. When A cross B is perpendicular to C, so this equation implies this. Now we'll take A cross B. We already know that A cross B direction is this. A cross B is perpendicular to both A and B. So A cross B is perpendicular to A, B and also C. When is this possible? When all the 3 are in the same plane. When A, B, C are coplanar. So this is if part. Now only if part is like this. Suppose that A, B, C are coplanar. Suppose that A, B, C are coplanar. Then it implies that they all lie in the same plane. Now A cross B is perpendicular to both A and B. We know that A cross B is perpendicular to both A and B. So this also implies that because A, B, C are in the same plane, A cross B is also perpendicular to C. A cross B is perpendicular to C. So that means A cross B dot C is equal to 0. So like this we prove the other part of it. When A, B, C are coplanar, then A cross B, we know that A cross B is perpendicular to both A and C. So A cross B is perpendicular to C also because they are in the same plane. So their dot product should be equal to 0. So that means box ABC is equal to 0. That is how we prove the theorem. Okay, next is volume of a tetrahedron. What is a tetrahedron? What is a tetrahedron? Tetrahedron, this is the term. It is a solid tetrahedron. It is a solid where all the sides are triangles. All the four sides are triangles. So suppose that this is the base and this is the one side and this is another like this. So suppose that O, A, B, C are the vertices of a tetrahedron. If you could follow this figure, OAB is the base. OAB is the base. OCA is one side. CAB is another side. And back side. COB is that side. So there are four triangles in this. Base is triangle. All three sides are triangles. Now this is the solid. Suppose that OA is A, OB is B and OC is C. That means ABC are the coterminous edges of the tetrahedron. Then the volume of the tetrahedron. Then the volume of the tetrahedron is given by 1 by 6 into box ABC. Just learn the formula. Modulus of 1, because sometimes you may get negative value, but volume is always positive. So it is 1 by 6 into box ABC. Now this is the formula. When three edges, three sides are given, this is the formula. There are some problems where they give the vertices. That means, suppose that instead of OABC, suppose that ABCD are the sides, are the vertices. ABCD are the vertices of the tetrahedron. So that means OA is equal to A is equal to, they'll give some point. OB is equal to B is equal to, like this points are given. OC and then OD like this. OC, B, C and D like this. So 4 points are given. Then you convert them into vectors. Always when 4 points are given, you convert them into 3 vectors. So what are the 3 vectors? AB vector, AC vector, AD vector. See that the initial point is same. AB is OB minus OA. OB minus OA. Next AC is OC minus OA. AD is OD minus OA. So like this you convert the 4 points into 3 vectors. Now they form the sides. So this is our A, B and C, and then you apply the same formula. So when you are given the vertices, then the formula becomes 1 by 6 box of AB, AC, AD. So you have learned about the volume of a parallelepiped. Volume of a parallelepiped is just box ABC. And ABC are the 3 coterminous edges of the parallelepiped. Now for tetrahedron, 1 by 6 box ABC is the formula. 1 by 6 box ABC is the formula. Okay. Now we'll summarize all these points. What all we have learned we'll write and then we'll do the problems. So only you have scalar triple product in your syllabus. Vector triple product is deleted for this academic year. So we'll write all the points and then we'll do the problems. So we discussed all these points. A, B, C are 3 vectors. Then A cross B dot C is called as the scalar triple product. And then ABC, box ABC is 0. Then either one of ABC is 0 or AB or BC or CA are collinear vectors, or C is perpendicular to A cross B. So the volume of a parallelepiped with edges as, so these are the edges A and then this is B and then this is C. So the volume of the parallelepiped is box ABC is modulus of, sometimes we may get negative. If they are in the left hand system, then you will get negative value. Whatever it is, you take the modulus of it. So volume is positive. Box product of ABC is the volume of the parallelepiped. And then when the cyclic order is the same, A box ABC is same as BCA is same as CA. Box BCA is same as box CAB. So when you interchange in a box product, dot and cross can be interchanged because it is the volume of the same parallelopipe, right? And then when two vectors are identical, then the box product value is 0. And when you interchange two vectors, then the box product changes its sign. And then LA plus MB plus MC box product, LA, MB, MC box product is LMN into box ABC. That means if you have 2A, just now is explained, 2A, 3B, and then 4C box product like this, then it is equal to, multiply these three numbers, 4 3 is 12 is 24. So it is equal to 24 into box ABC. Like this. Now we'll continue with the next properties. So this is the next point. Box IJK is equal to 1, and then ABC are in terms of IJK. Then this is the formula. When LMN are three vectors which are in terms of ABC, then this is the formula. Then volume of a tetrahedron, as you know, the tetrahedron is a solid which has all sides as triangles. So volume of a tetrahedron is 1/6 box ABC. If you are given the sides vertices, then this is the formula. And then you have the next theorem. Next theorem, if ABC are coplanar. So next point is 13th point. So ABC vectors are coplanar. ABC vectors are coplanar if and only if are coplanar if and only if their box product is 0. If and only if their box product is 0. And then yes. So this is the next property. If ABC vectors are coplanar. Okay, now we'll do the problems. 1 or 2 problems we'll do, and then we'll complete. Okay, next first problem. Compute box I minus j, and then j minus k, and then k minus I. Find the value of this. So it is nothing but I minus j cross j minus k. Anywhere you can put cross, and then dot of k minus I. So it means actually when you are putting cross here, it means it is the bracket is there for these two like this. So according to our formula, it is like this. This is nothing but I minus j plus 0k. It is nothing but it is I minus j plus 0k like this. And then second one is 0i plus j minus 1 into k like this. And third one is minus I plus 0j plus k like this. These are the three vectors. So their box product is, now write the coefficients, 1 minus 1 0, and then 0 1 minus 1 minus 1 0 1 into box IJK. This is what we studied. So now it is equal to, now find the determinant. So it is 1 into 1 minus 1 into plus 1 into delete the row. This is minus 1. So this is minus 1 and then 0. So it is box IJK is 1 into 1. So its value is equal to 0. 1 minus 1 is 0. You find the determinant value. Box IJK value is 1. So it is into 1. So it is equal to 0. So like this we do the problem. Now next one is second problem. Suppose that A is equal to I minus 2j minus 3k, and then B is equal to 2i plus j minus k, and C is equal to I plus 3j minus 2k like this. Now compute A dot B cross C. Compute A dot B cross C. A dot B cross C is nothing but same type of problem. Here he has given A, B, C vectors separately. So it is nothing but box ABC. So that is equal to determinant of 1 minus 2 minus 3, 2, 1 minus 1, 1, 3 minus 2 into box IJK. into box ijk. So just to find the determinant value, you will get this number as minus 20 and this you will get into 1. So the answer is minus 20. So like this we do the problems. Now we'll continue in the next page.
ఆ చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు షురు అదే డిజిటల్ గురు అదే డిజిటల్ గురు
वो कोई और हो